Okay, today we're reviewing for your trig test. Please make sure you watch this video in its entirety. If there's a certain concept that you don't understand, then go back and look at the videos that I recorded over the lessons throughout the trig unit. The first problem you had was on page 369. We're going to look at number 48, which is testing the Pythagorean theorem. So you had a right triangle with a hypotenuse of 45, a leg of x, and a leg of 8. We know Pythagorean theorem means you take a squared plus b squared is unknown equals the c squared, which is 14. You square 8 squared, which is 64, plus b squared equals 14 squared, which is 196. To get that b by itself, let me zoom in a little bit so you can see a little bit better. You subtract 64 on both sides. And so we get b squared equals the square root of 132. Is there a square root of 132? There is not. Remember, we do not round unless it tells us to round. If not, you always write it in simplest radical form. So we're going to take this 132 and we're going to reduce it to 2 times 66. 2 is a prime number, so it's going to come down. We're going to break 66 down, and 66 can break into 2 and 33. So I have a pair of 2's. Can 33 break any further? Yes, it can break into 3 and 11. And that's as far as it can go. So our final answer is 2 radical 33. Got it? The next problem was number 54. I'll write that over here. So I'm kind of going to be jumping all around the page. And 54 says, tell whether the side lengths of the triangle is obtuse, acute, or right. If it's right, then that means that it's going to be a squared plus b squared is equal to c squared. If it's obtuse, that means a squared plus b squared is less than c squared is greater. And then if a squared plus b squared is greater and c squared is less, then it is an acute triangle. And so you can go back in 5-7 and relook over that if you don't understand it. So if we look at this problem, we have sides of 2 squared plus 3.7 squared. And I'm going to leave this blank and I'm going to put 4.1 squared. And so when we did 2 squared, we have 4. If you square 3.7, you get 13.69. We don't know if it's equal, greater, or less. But we have 4.1 squared. And that is going to be 16.81. When I add the 13.69 plus 4, I get 17.69. And so I know that's greater than 16.81. And so then that means that this triangle is an acute triangle. Why is it acute? Because a squared plus b squared is greater than c squared. Bigger than the secant squared, so it's a acute triangle. The next problem you had is down at the bottom in 5-8. 5-8, we have number 56. And this is bringing us to our special rights. We have a right triangle with sides x, x, and 12. When you look at this triangle, you notice that x and x means that the two legs are congruent. On a right triangle, if it's congruent, that automatically tells us that this is a 45, 45, 90-degree triangle. For those of you who came in our workshops or looked at the previous videos, remember this is on your formula chart, and 45 degrees is worth x, 45 is worth x, and the 90 degree is worth x radical 2. So always start with your given. We're given 12, which is the hypotenuse, so we know that it goes right here. So that means 12 is equivalent to the x radical 2. So I'm going to set 12 equal to x radical 2. And so now we can solve this so we can figure out how much x is equal to. We divide both sides by by radical 2. That cancels. X equals 12 over radical 2. But we cannot leave it like that, so we have to rationalize. With rationalizing, remember you can't have a radical denominator, so multiply the numerator and the denominator by a radical 2 or radical 2 because it's equivalent to 1. And so at the top we get 12 radical 2 divided by square root of 2, and square root of 2 is square root of 4, which is equal to 2. We simplify by dividing 12 divided by 2, and so our final answer is 6 radical 2 is our x. So each one of those are worth 6 radical 2 and 6 radical 2. And that's the answer for number 56. Got it? Okay, let's look at, let me scoop my paper up. The next one, which is number 60. And remember with 60, we have a right triangle. This is 60 degrees, so we automatically know the triangle sum is going to be a 30, 60, 90. This side's 14, this side is y, and that side's x. Just something food for thought. Remember, a 30, 60, 90 triangle can be drawn from a equilateral triangle. And remember, on equilateral triangles, and this has nothing to do with this problem, I'm just telling you. Remember, equilaterals are 60, 60, and 60. So when you split an equilateral triangle, then it cuts it into a 60, and then these two would be 30. Just saying it while I'm talking about it. So let's ignore this. Just wanted to remind you about equilateral triangles being 30, 60, 90s. So start with our given. We know that 30-degree triangles have the shorter leg is x. 60 degrees on the 30-60 is x radical 3. And 90 degrees is worth 2 times the shorter leg, x. Which one is shorter? Whichever one is across from the 30-degree angle. So we do not know the 30-degree angle. We also do not know the 90-degree angle in this problem, but we are given 60, which is across from the 14. So we know that 60 degrees is worth 14. So we'll start with our given and work our way backwards so that we're able to find those two. So we have 14 equals x radical 3. Divide both sides by the square root of 3. That cancels. We get x equals 14 over radical 3. We're going to rationalize, and so it's equal to 14 radical 3 over square root of 3. Square root of 3 is 9. Square root of 9 is 3. And so that is how much x is equal to in number 60. Everybody got it? So this answer is 14 radical 3 over 3. Now that we know that, we can also figure out the y. See, y is across from the 90-degree angle. So we know x, so basically we're going to take 2 times that x, 14 radical 3 over 3. And we multiply 2 times the 14. And we get 28 radical 3. And don't forget, it's all still over 3. 28 cannot divide into 3 evenly, so that is our final answer. And so this answer is 28 radical 3 over 3. And so those are our 2 answers. Remember, on special rights, start with the given. Everybody got that? Okay, now we're going to look at the next page, was page 530. Number, let me find it and pause.